Good morning, one and all, and once again, welcome back to the video. In today's deep dive video, I welcome you all. I'm gonna be your host instructor for this particular video, and the goal is to show you how to build a modern data lakehouse architecture. To build a modern data lakehouse architecture, we are gonna be leveraging EMR serverless, to process our data. We'll be using Hoodie Streamer. And with Hoodie Streamer, we're going to be using Hoodie extension from Apache Xtable. This allows the Hoodie Streamer to build the metadata for Iceberg, Delta, and of course Hoodie after every single commit. After that, we're going to be using Glue Crawler to crawl the data, and then we'll query this data in Athena. We'll query this data as a Iceberg table in Spark. We'll query this data using Hoodie in Spark, and then we'll query this data using Snowflake. So this is a complete deep dive video. It's going to be a long video where I will walk you over all the steps, process, lab materials, IAM roles, policies. We're going to do everything step by step. The goal is to educate and inform you about the modern data lakehouse architecture. So before we begin the video, I simply ask you to like, share, and comment on the video. That way it really helps the channel. So now with that being said, let's begin the deep dive modern data lakehouse architecture. So just a prerequisite before we begin this even particular data lakehouse architecture, there are some items that you need to prepare in order to do these labs with me. Number one, you need a Amazon AWS account. You need your AWS access and secret key, and making sure that these keys have access to most of the services. After that, you would need a local environment that has Docker, so you can run like Docker containers. So these are the prerequisite that we need. Before we also begin, I want to just show you this diagram. Hopefully this made sense, right? So the sources could be JSON, CSV, Kafka, JDBC source, or Hoodie. The compute engine is going to be EMR serverless with Delta Streamer. You can also apply transformation. And then the storage is going to be S3. And here you can see I have three logos for Iceberg, Hoodie, and Delta. Using glue crawlers, we're going to catalog the data in Glue, Hive, Metastore. And then we'll be able to query this data in any query engine of your choice. This could be Snowflake, Athena, Spark, right? So hopefully the overview makes sense, and now it's time to get started. All right, so the first step in the process is you are given a Google Drive link and you need to download these items on your local machine. So you can see this is a Google Drive link. Again, this is given to you. There's a test folder. You will see a sample Parquet file inside that. And then you will see a jar folder, and these has some bunch of jars with it. Again, remember, these are important. The versions are also important because I will be doing it on EMR 7.0.0, and these are the compatible jars. So please make sure to get all of these jar files over here. So step one, okay, right click, download this from your Google Drive into your local machine, and then head over to S3. Okay. And then create a folder called raw. Inside raw, create a folder called Parquet, and then upload these files into that. So these are your raw Parquet files which are coming from any sources. So step one, make sure you upload them. Step two, upload your jar files on S3. Okay, here you can see jar folder, and then these are all the 4 jar files that I have. Hoodie extension, snapshot bundle jar, Hoodie Java client jar, Hoodie Spark 3.3 bundle jar, Hoodie utility slim bundle jar, and JCommander jar. So these are all the jars that you need. So make sure you download them. Okay. So first step, open your AWS management console, head over to S3, upload the raw file into the Parquet upload the raw Parquet files into the folder that I just showed. Upload the jar files into the folder jars. So hopefully you've done with this particular part, and now we can move with the next part, which is let's create an EMR serverless cluster so that when we submit a job, it's gonna do our processing, right? So I'm gonna show you that part. All right, so to go to EMR, you can simply head over to this button. I prefer choosing the serverless, so I'll choose EMR serverless. Click on manage application. You'll see I already have one. So you can click on the console and just say create application. Again, the cost won't be that much. It'll be like just $1 or so. So my Spark. I'll say my Spark cluster, and the version would be important, which would be 7.0.0. Everything else, just leave it to default, okay? And make sure in the default setting, I assume that this would be enabled. So Glue Hive Metastore is enabled, okay? And then click on create application. I already have an application, as you can see, it's called Spark Cluster, and what you want to do is copy this particular application ID on a notepad. Here you can see EMR 7.0.0. So hopefully you are done with this steps. So, pause the video right here, go ahead, create that EMR serverless cluster, upload these files on S3. And now the next part is basically we're gonna submit the job. So let me share my screen. Hopefully I can find that. Okay, I think I did. Okay, so don't worry. Again, I like to make things easy, not difficult for you, as you know. So in simple language, I wrote a Lambda function. I'll explain you what it does. It takes an event and it's gonna submit a job to EMR serverless. Okay, so simple thing, this Lambda function only submits job to EMR serverless. So here you can see, again, I like to think of everything as a template. So jar, okay, so here you will see all the jar files. You will need 4 jars. We're gonna be using the default one that comes on EMR. It comes under user lib hoodie utility bundle jar. So it's inside that folder. This jar is there, okay? Then I wanna use hoodie slim utility bundle jar. I'll be using hoodie extension snapshot jar and hoodie Java client. So easy, right? Nothing I need to explain here, hopefully. So these are the Spark submit parameters that we're gonna be using. The most important one being is here. Class auth.apache.hoodie.utilities.delta-streamer.hoodie-delta-streamer. I'm gonna be using that. And then we are also using the Glue Hive Metastore class, as you can see over here, right? So I'm gonna collapse that. And now comes the arguments. So these are the hoodie streamer arguments. So the table name is gonna be copy on write. Hoodie offers both copy on write and merge on read. Operation is gonna be upsert. These are the 2 important ones that I'm gonna talk about. Sync tool class is gonna be set to io.onetable.hoodie.sync.onetable sync tool. So this is the sync tool that we're gonna be using. Enable sync, we're gonna set that to true. Replicate, this is these, for deduping, I'm gonna be using a timestamp attribute. I'm ingesting data from Parquet, so I'm using this particular class. Again, if you're ingesting from CSV, use that particular class. Target, we're gonna be building our hoodie data lake inside a folder called silver. Target table is gonna be invoice, and these are the configuration. The important one that you wanna know is here. Here I'm saying hoodie one table format to sync. I'm gonna be providing that as iceberg. Hoodie one table target metadata retention. So how long you wanna retain the metadata. And then of course we define our primary key, our dedupe key, and then where you wanna read the data. So this is the path from where we're gonna read the data. So that's about it. And again, these are just standard job parameters, right? I provide the EMR application ID through an environment variable, and then I provide the execution ARN through an environment variable. Again, you're gonna have these steps. Again, I'm gonna do a pretty good job at everything, okay? So first, what I will do, I'm gonna bring my terminal here. This EMR serverless ID, I remember how we got it from here, right? So I'm gonna export one by one. So I'm gonna do that. Then I will export the bucket name that I'm using and the role. Okay, so now I will be firing the job. The way I will fire the job is I'm gonna run this particular file, fire emr job.py, and before that I wanna also show you that there are no jobs in the running state at the moment. Okay, so Python 3 fire job.py. Now, as you can see, it does print all the configuration on the console, and now it's also polling it submitted a job. Now, after submitting the job, it's polling for the status of that job. So if I go to EMR, you'll be like, hey, but I don't see any job. Well, you just need to refresh here, pending, right? So here you can see the job is in the pending state. So at this point, I think I'll pause the video. Once probably in the running or completed state, I can resume it. So right now I am simply pausing the video right here. All right, so the job status, as you may see, has changed to running. And if I simply refresh my EMR console, I can see that into running state. I think EMR, probably should have done this, right? I don't know, like the state doesn't change on the UI, right? I have to refresh it. It's kind of a little annoying. Like as customer, you wanna see that on the UI. So hopefully they make that changes in the future. Anyway, I can click on the job. You can see all the parameters that were submitted, etc. So now at this point, let's go to H3 and see if we do see any folders. Okay, so I'm gonna come here and refresh, and here I can see a silver. I do see a folder called invoice, and this is good actually. We see all the folders populated. We see the hoodie related metadata, and let's see if iceberg metadata is there. So metadata, I'm gonna search. So far the iceberg related metadata is not there because the job is still running, right? So it's still doing all that work for us. So let's go back. Just go back to my cluster. Is it complete? Looks like it is complete. It just got completed. Yep, it's success. So now I'll go to the H3 and I can try metadata. I'm just going to refresh and then put enter. There you go. And I can see the iceberg related metadata. I see these JSON files and the version hint.txt file. So that's great. Well, that's great. We got this, at least the basic one working. That's good. Now the next one, what we need to do, again, we got that. Now we're gonna create a glue database. So we're gonna create a glue database called iceberg DB. This is just a shell command, but you can also, you know what, I'll just redo it. That's fine. I'm just gonna delete it from here. All right. So now that you have that, I'm gonna issue a command AWS glue create database, and the database name is gonna be iceberg DB. I hit enter, and now if I refresh, there you go, iceberg DB. Now I don't have any table inside that, of course. So now what you want to do is we're going to create a crawler, right? So click on this copy H3 URI. This will copy the path to this, okay? And then what we will do is we're going to create a crawler. So now I'm going to copy this command, AWS glue create crawler. We're going to give it a name. I believe the crawler already exists. Let me just double check, because if I fire this, it's probably just going to say, you know, yeah, it already exists. So I'm going to delete this so that I can do each and every steps with you. All right, so we got to create this crawler, and of course you will change the path because again, in my case, my bucket name is this, but your bucket is going to be different. So make sure to change it. So let's fire this guy. All right, so done. And then if I refresh, all right, so that's the crawler. If I click here, data source over here, for some reason okay, yeah, the type is iceberg and that's the path. Okay, so what we do is we're gonna run it. You can of course, you know, do it through the console, but I like to do things on the shell. So I'm gonna say AWS glue start crawler, and I'm gonna give it a name, the name of the crawler. And yeah, the crawler has now been started. So now if I go to crawlers, and if I want to simply refresh it over here, and you may see that this is now in the running state. Now this takes about a minute or so. The crawler is gonna crawl and it's gonna now populate the table in the Glue Hive Metastore. So let me see if we refresh. Yeah, it's still in the running state, 20 seconds. Okay, so yeah, let me pause the video again and then resume once the crawler is complete. So the crawler is just completed. As you can see, it took about 1 minute and 18 seconds. That's not bad. And then let's go to databases, iceberg DB. And I think we just need to issue a refresh, and here you can see we have a table called invoice, and it's been cataloged inside the database name called iceberg DB, and that's the location. So great, so we got that. Now let's try to see if we can query with Athena at this point. Gonna switch to that to iceberg DB, simply do a refresh. I see a table. Let's do preview table. And sure enough, I see all the data. Lovely. I mean, I am able to query this as iceberg. Okay, so that's great. So at least we you know, sorry about that. So at least we got this data up and running. We can query this using Athena. That's great, fantastic. You can query this as Delta, Iceberg, or Hoodie in Spark. Now, hey, you'll say, hey, Soumil, but you said we're gonna do Iceberg, Snowflake too. Well, yeah, I'm coming there. It's just a lot of steps, you know. So at least you got that working. So that's great. Pat yourself. And now we're gonna do the Snowflake part. So again, for Snowflake, I assume you have a Snowflake account. So I have a demo account. So yeah, I'm gonna share my screen now. So before even that, before doing Snowflake, I think there are some prerequisite steps that we need to do. So the first one we would need is a Snowflake role. So I'm gonna probably try to show you. Yeah, you just need to create a bunch of IAM roles and policies first. So all right. So for Snowflake, I have this role, as you can see, and if you expand upon this, these are the access that I have. Excuse me. S3 access, just basic S3, right? So I have that, and then the important thing is the trust relationship. I'm gonna do that in a second. So now what you want to do is, first I'm gonna go to Snowflake. I already have a database called TempDB. I made that. Again, we're gonna use that database. So let's try to use the TempDB. Okay, and then we're gonna create an external volume, and we're gonna put the path over here. As you can see, this is the path to our silver zone. Okay, we are not providing the exact path, but we are providing an absolute path, as you can see, and that's the IAM role that I have. Okay, so let me copy this one, and I'm gonna fire this up. And as you can see, now we have the external volume, and now I need to update the IAM trust policy. All right, so now that you have that external volume on Snowflake, and now we're gonna be firing a command des external volume. So I think I'll just run this one. And now you see this JSON. What you wanna do is you wanna probably use either ChatGPT to format this. So I'm just gonna say format the JSON so that I can just read it in a nice way. And after that, I think we need to copy a couple of things. I'm gonna show you that. Okay. So, okay, let it do its thing, and then we need to copy these two things from that. So let me see my notes quickly. All right, so we will copy storage AWS IAM user user ARN. I'm gonna do that again. So storage, let's see. All right, this one, storage AWS IAM user ARN. So I'm gonna copy this guy. Okay, and let me see. Yeah, sometimes my Mac. All right. Anyway, so now let me see, where is my IAM role. Open up. I need to go to that role. Okay, yeah, here. So I'm gonna open up that role, Snowflake role. I go to trust relationships and click on edit, and you see this guy over here. You just need to update that. Okay, so I'm gonna replace that and then click update. So great, you're done with that part. So now you have an external volume, and now what I need to do is I need to link my Glue Hive Metastore. So I'm gonna do that. Similar steps. So before I do that, let me go here. Okay, so you see this Snowflake Glue access one, right? That's again another IAM role for Glue databases. So I'll show you. So roles, this one, and here you can see Glue database, get tables, etc., making sure it has access to catalog and databases. Again, this policy is given on the Snowflake website. I'll leave the resources in case. Okay, same thing, right? Once you do this, then you need to update the IAM trust relationship, right? So I'm gonna create that. Remember, important, Iceberg DB, right? That's the database I'm trying to access. Okay, so let's put this guy rolling. So that's done. And then I'm gonna describe that just like we did with the external volume, right? So describe catalog integration, SF Glue catalog integration. That's the name I gave. All right, so I got that, and now I need to copy a couple of items in that. I remember that. So we're gonna be copying Glue AWS IAM user ARN. So Glue AWS IAM user ARN. So let's see where that guy is. Glue AWS IAM user ARN. So I think that's the one I need. And also let me just right click and copy, because sometimes I don't know why. I think this one over here. So I'm gonna replace that. Did I even copy that? I just want to make sure I copied. So it ends with 0000. Yeah, I think I did copy, and then S. Okay, and then we're gonna be copying this Glue AWS external ID. I think that's the one we need. Yeah, Glue AWS external ID. Yeah. So right click, copy this guy, and then put that in the notepad. Okay, and now same thing, guys. We'll go to this particular role, Snowflake Glue access role, which I believe I have it on somewhere on the open up, probably here. Is this the one? Yeah, that's the one. Trust relationship. Edit trust relationship. Now same thing, man. Just keep posted. So now I'll copy this. Right click, copy, and then okay. So that's done. And then I will copy this one, and then I will probably do this, and then I'm gonna click on update. Okay, so that's done. So now back to my Snowflake. I will put this drop down back. All right, so that's done, right? So now what we can do is we're just gonna create this table. So I'm gonna read this out. Okay, so create or replace iceberg table, and we're gonna name it invoice. Okay, because remember, so now I wanna actually navigate. So it's an invoice table, right? So if you go to Athena, where is Athena? All right, invoice. Okay, so in Snowflake, I'm gonna, and even in my Glue Hive Metastore, it's invoice. So I'm gonna create this now. So let's see what happens. Again, I do not have an invoice table here on the on this pane, as you can see, but when I do so, I will have one. All right, so it's running. All right, it's done. So now just refresh. Here you can see. Now let's see if I can query the same data in Snowflake. So select everything from invoice. Great, I think it should just work fine. There you go, lovely, man. I can query this in Snowflake. I can query this in Athena. Fantastic. I can also query this in Spark. So count star 68 records. Okay, and let's head over to Athena. The count has to match. It's gonna match, man. It's no brainer. All right, 68, perfect. And I know I said Spark as well, so so let me see if I can probably pull that up. So what I have here is I have my so again, you can locally run Glue notebooks. You can run Glue locally on Docker containers. I have a video. I'll leave the resources. So I already have that notebook spinned up, but I think I'm gonna first show you. Hold on. So I want to show you the repo. So Glue, I believe that's the one. Yeah, no, not that one. Yeah, this one, run AWS Glue local. That's the, yeah, this one. So run AWS Glue locally, right? So steps are given. Okay, so I have that notebook. So I'm gonna show you to query the same data in Spark now. So here again, this is gonna be a bit slow because I'm running that through a Docker container. I'm running Spark through a Docker. Okay, so here I'm gonna, once this Spark session is created, I'm gonna query the same data. As you can see, I'm doing count star iceberg snapshot and then hoodie snapshot. Okay, so same one. Okay, so I'm gonna run this again. It will be slow locally because I am running on a Docker container. The memory is limited, so it's gonna be slow. But again, you can always do the same thing on AWS Glue notebooks. But again, the reason I'm not doing is it's gonna add additional cost on to my stuff. Like I'm doing it locally, so I'm trying to keep my cost minimum, right? So if it's slow, I'm okay with that, right? But again, I just want to show you everything. Like, hey, I can query this in Spark, I can query this in Snowflake, in Athena, everything, right? So hopefully, let's wait for a couple of more seconds. So it's gonna, yeah, as you can see, 68. So my point being is the count is matching, right? So what you learned is, hey, you were able to query this data using, of course, Athena as iceberg table. You can query this using Hoodie, of course, either in Athena. If you want to use it in Athena, then you need to use the Glue crawler, and then you can use. So if you want to query this as a Hoodie table in Athena, then you can use the Hoodie Hive Sync tool, or you can use the Glue crawler, right? Either way, both works fine. So that's sorted. Athena thing is sorted. Then if you want to query this in Redshift, then I believe to query this in Redshift, you can. I believe I've done a video, and I know this because you can mount the glue catalog in Redshift Spectrum, and then you can query this data. So that's sorted out. You can query this in Redshift, you can query this in Athena. I just showed you Snowflake, so that's great. You can query this in Spark, either as Iceberg, Hoodie, or Delta. So great. So you as a user, you're not locked in into any particular table formats or any engine. You decide which table format you want to choose. You decide which engine you want to choose, which best suits your applications and needs. You can also query this natively using Python. I believe Daft is one of the library, Hoodie, Rust is the library, and there are several other libraries. So it's a universal table. Now engineers, developers, data scientists can query this data. They can consume it in their AI models if needed, right? So one table, one copy. You just have one copy of your data, and it can be consumed anywhere, right? So hope that makes sense. And by leveraging Hoodie, you can do incremental ETL, other for further downstream processing, faster writes, multimodal indexing, all that stuff, right? And then you can use Iceberg, Delta, Snowflake, Athena, Trino, Presto, Starrocks, anything, right? So I hope this video was insightful. I know there's a lot of steps and materials here, but I would need some more time to put the blog with all the steps and resources. So I'll put this video on YouTube, but the blogs and resources and the steps are gonna take a while because I have to prepare all of these. Now, if you believe I've done a fantastic job, all I ask you in return, please make sure to give a like, subscribe to the channel, and share the video with your coworkers and colleagues. And I will be seeing you in the next video. Thank you.